Today I will discuss the part 3 chapter of my lecture. The part 3 chapter contains two parts, that means named reaction and rearrangement reaction. Today I will discuss the rearrangement reaction. First of all, I will discuss the organic chemistry, that means the basically carbon chemistry. Organic chemistry, basically the carbon chemistry, and the one compound is converted to one compound is converted to another compound by the process is called the reaction. Any substrate react the reagent and convert it to the product. That means substrate is the initial compound and product is the final compound, and the reagent which proceed the reaction, and the rearrangement reaction means rearrangement reaction is the one group or atom of that molecule is migrate to another positions of that compound. That means A and B, A is connected to the Z, and after the rearrangement the product is this A is called the migratory origin, and Z is called the migrating group or atom, and abbreviation is 1, 2 third bracket ZC. This is the abbreviation of the rearrangement reaction. Now I will take an example of the rearrangement reaction is CH3 OH, CH3 OH. This compound is called pinacol. This pinacol treated with acid or any acid source such as sulfuric acid or sulfuric acid plus acetic acid. This compound goes to the keto compound. This compound is called the pinacolone. Pinacol in presence of acid convert it to the pinacolone. So this type of reaction is called pinacol pinacolone reaction or pinacolone rearrangement. Okay na? Pinacolone rearrangement. Now I will see the reaction mechanism of the pinacolone rearrangement. Now the mechanism of this reaction. In the presence of acid, this OH group is protonated, and this process is the reversible process, and form this compound, and this water group is the leaving group and leaked from here and to form the carbocation. Now the lone pair of oxygen push here, and this methyl group shift here, and this is 1,2 Me shift, and to form the rearrangement product. This one, and this also resonance stabilized by this carbocation, and finally this compound lost a proton to form pinacolone. Okay na? This is the final product. Now the moves to the driving force of the migrating group. This methyl group is migrate. What is the driving force of the migrating group? The driving force of the migrating group is the resonating stabilized carbocation. That is resonating stabilized carbocation. This carbocation and this cation, this is the two resonating structure. This resonating structure carbocation is much more stable than this tertiary carbocation. This is the 3-degree carbocation, and this is the resonating stabilized carbocation. This oxygen is resonate, and this cation here. This resonating carbocation is more stable than 3-degree carbocation. So this resonating carbocation formation is the driving force of the rearrangement reaction. Now this methyl group does not detach from the carbon skeleton. This methyl group does not detach from the carbon skeleton. That means this rearrangement reaction is intramolecular reaction. This rearrangement reaction is intramolecular reaction. That means the lone pair of oxygen is pushed and this methyl group shift to here. This is the simultaneous process, and do not detach from carbon skeletons of the methyl group. And this intramolecular rearrangement is fully evidenced by the crossover experiment. That means the crossover experiment. The crossover experiment means that pH, and C, Me, OH plus Me plus C, pH, OH, This two compound is mixed and will titrate the acid to form the compound this compound plus this compound, but this compound and this compound does not form. So this rearrangement reaction is intramolecular. By this crossover experiment is fully supported, this reaction is intramolecular. Now I will go you forward some example, and the other example I will see the pH, OH, and pH, OH, but the two hydroxy group are symmetrical. So which one first protonated does not matter, but the pH, OH, and Me, OH. These hydroxy group are asymmetrical, and these two of them, one of them are protonated first. And which are protonated? The protonated OH group leaves and to form the carbocation, and this carbocation is more stable. Which one is leave? The two possibility, either pH, Me, OH, or pH, which one is more stable? This carbocation and this carbocation. This carbocation is more stable and less stable. This carbocation is regenerated by the phenyl ring, and this is the more stable. So this OH group is first protonated and leaves to form the carbocation, and this methyl is shipped here. So the unsymmetrical hydroxy group, in presence of unsymmetrical hydroxy group, and the preferential hydroxy group is protonated and leaves and to form the more stable carbocation. Now the other example is PHC Me OH PH CF3 and OH. Which one hydroxy group is first protonated? Now the CH3 group is electron withdrawing, and due to it has minus I effect and electron withdrawing from here. So the formation of carbocation here, is highly unstable. Due to the electron withdrawing effect of these groups. So this OH group is first protonated and to form carbocation, and this methyl group is shipped here and to form PH CF3. Now I give some example of this reaction. Here I gave some example for pinacol rearrangement. Before we discuss these examples, I have some discuss given here. First of all, we see some things. Number one, first the substrate I will see is perfectly, and if the two OH group present in the vicinal carbon, if the two OH groups is present in the vicinal carbon, and the reagent is acid or acid catalyzed, then this reaction is goes to pinacolone rearrangement. Okay now, first of all I see the two OH group presence are not in the vicinal carbon. If yes, then the reaction medium is acidic or base. Is acidic, then you go to pinacol, pinacolone rearrangement. But one thing is more important: which group is migrate? Which group is migrate? The migrating aptitude is depend upon the electron donating ability of the group. That means the rearrangement reaction is involved the movement of the migrating group with the bonding electron pair. That means bonding electron pair is moved to the electron deficient center. Here I will discuss some migratory aptitude of these groups. Here the para methoxy H4 is greater migratory aptitude than methyl para-methyl phenyl groups because the para methoxy group is greater migratory aptitude than para methyl groups. Here the electron donating ability of this oxygen is more due to plus R effect, and this also have plus I effect, and this donating ability is more, so this group is greater migratory aptitude than this. Another example is the parachlorophenyl group is less than the phenyl group. Okay, this is the electron withdrawal effect of due to minus I effect. So this group is electron withdrawing, so the migratory aptitude of this group is less. So let us move to this example. Which one is migrate in the first example? Here, which one is first protonated and which one is the migrated? Okay, the first protonated of this is this compound is first protonated because this is first protonated due to the regionally stabilized carbocation is formed and regionally stabilized carbocation is formed, and this group will be migrate here. So finally from this product is nitro, and this is OMe, para-OMe. This also OMe, this also OMe. Okay, this is the final product of this example. Now let the second example of this reaction is which one is the protonated first. So this is the carbocation. This OH group is first protonated, and the hydride shift here, and the final product is this one is the final product. The migratory aptitude of hydride is more than methyl because the migrating after the migration the carbocation is formed here is more stable due to this presence of methyl. So the migratory aptitude of hydride is more than methyl groups. So this is the final product of this reaction. Now third one, this is the symmetrical hydroxy group is the symmetrical, so any of this is protonated and this bond shift here and the formation of this is this is the final product of this reaction. Now here also the same things. That number 4 is the same hydroxy group is the same position. So anyone can protonate it, and this also move here and this also move here. And now this final product is the final product of this reaction. Now the fifth example of this reaction is the white, here also white. Now here is the possibility of the two OH group is similarly stable formation of the carbocation. So there is two product is formed basically. The first is the carbocation from here, and finally OH and methyl shift here, and this is the product. And second product is ring extension. Ring expansion formation. This is the final product. Now finally the pinacol pinacolone, that means wall means alcohol and on means ketone. That is the alcohol is converted to ketone. That means in pinacolone rearrangement, the alcohol converted to the carbonyl compound. That is, do not only for ketone, that is aldehyde also. Aldehyde and ketone, that means carbonyl compound. The alcohol go to the carbonyl compound. 1,2-diol, vicinal 1,2-diol is go to carbonyl compound in presence of acid in presence of acid, that is called pinacolone rearrangement. Now I go to forward the another example here. The carbocation formation. Now the another part of this reaction is the carbocation formation is the fixed. That is a fixed position. Carbocation formation position is fixed. Okay, the carbocation formation position is the fixed. Now the example is methyl OH C methyl NH2 have this compound is treated with, that is NaNO2 plus HCl. This reagent formation of HNO2, this reagent is converted this compound, this NH2 amine group is converted to N2 and this N2 this is the leaving group and leave here, this part is leave and to form the carbocation, and this migration here and this finally form this compound, okay na? The final compound is this one is the final compound. Now the another example of this reaction is this type of reaction is treated with AgNO3 silver nitrate, and this reagent is form the carbocation here. That means this halogen is leave by this reagent, and to form this carbocation this is the carbocation formation, and this phenyl group is migrate here, and this final product is this one is the final product. Now we go to forward directions. The another example of this reaction is the now this compound is treated with the acid. Now this carbocation is formed here, The carbocation is formed here, and this carbocation is pana, and this hydrogen group is shipped here, and the finally form the this compound. But this compound is racemic because this carbocation is rotate and this position will be changed. That means 180-degree rotate. Enough time to rotate. So this carbocation is formed to here and this also, and this is the final product is this one. This one is the final product. So this is the racemic product. Okay now? I'll discuss the pinacol rearrangement in cyclohexane system. Okay? Pinacol rearrangement in cyclohexane system. Now I'll take the cis diol, that is the cyclohexane have methyl white, that is the cis diol. Cis diol is treated with the acid and the product is formed. I will found. First, the cyclohexane structure in cis diol is the cis diol, that means down if equatorial, and methyl weight is axial, methyl is equatorial, and this weight is equatorial, and this methyl is axial. Here, the one thing is really remember that the leaving group will leave and the anti group of the leaving group is migrate. The requirement of the reaction is the migrating group is coplanar and anti to the leaving group. So this group, this OH group is protonated. If this OH group is protonated and from the cation, and this methyl group is anti to this departing group. This methyl group is anti to this OH group. So this methyl group shift here and finally form this molecule. Okay. Now, if this group is protonated and this bond is the anti-periplanar with this group, so if the carbocation from here and the this bond is shift here. The so the formation of this is the product is this. This will be this product form. Now, if the OH group is dense, the product is, I will find. Now, the OH group is anti. OH group is anti. Now, in the cyclohexane form, anti means axial, or equatorial, but here the oxygen and hydrogen make a hydrogen bond. So in axial, so in equatorial which is present, this more stable, so this form is more predominant. So this compound is treated in the acid. Here the one OH group is protonated and to form a carbocation here, and finally this bond will shift here and to form the compound is, that means this form a compound is this one. I can synthesize this compound, but this is the ring expression reaction. 1, 2, 3, 4, 5, 6, 7. But these compounds can be obtained by the another procedures. This is formed by the secondary, that means this is formed by the tertiary OH group is leave and to form the tertiary carbocation. But here the 1 degree carbocation is leaves and the bond shift and to form this compound. The another route I will discuss here. First, the main point of this reaction is leave in this OH groups, that means primary groups. So the procedure of this first step is this torsylation. In presence of pyridine, torsylations in presence of pyridines, that means the less hindered OH group is torsylated. That is the 1 degree which is the less hindered, so the primary alcohol is first torsylated. So it can give OTS. This is the torsylation product. And next, it can treat in basic medium or neutral medium, basic medium, base or neutral medium, such as calcium carbonate. This compound is gives to this one, and it can gives and form to generate a carbocation here, and this bond will be shift, and this is this final product. That means the primary hydroxy group is converted to tosyl, and then this rearrangement is occurs. This type of reaction is called the semi-pinacol rearrangement. This type of reaction is called the semi-pinacol rearrangement. Now, give the another example of this type is the OH, R2, R3, OH, R1, but it is give the acid, then it will gives this type of product. But in TS tosylations in the presence of pyridines, and then it is did the calcium carbonate, it gives the this type of product. This product is the pinacol rearrangement product, and this is the semi-pinacol rearrangement product. This is the pinacol rearrangement product, and this is the semi-pinacol rearrangement product. Semi-pinacol rearrangement product. Now, the pinacol rearrangement, it also occurs in presence of light and in the presence of solid state in the room temperature. That means here the pinacol rearrangement can also be occurs in presence of light. Here OH. This reaction can be carried out by the photochemically. This also gives the product this is the final product of this reaction. So the photochemically occurs these pinacol reactions. Now I give some example for your homework. Here some example I gives here. One is here product, Another is AgNO3. This one and 1, 2, and third this one integrate with the acid. Number 4. Number 5. Sorry. Number 6. Okay, so you can go your homework and you can follow your particular book, and more you can practice